This should not be possible. The spectral signature we are seeing defies every model we have for commentary composition. Washington blinks. The congressional battle for 3I Atlas data. Something shifted in the halls of power. This week, after months of silence, after perihelion came and went with nothing but whispers and speculation, the United States government is finally moving. Not because they wanted to, not because transparency suddenly became a priority, but because someone with actual authority decided enough was enough. Representative Anna Paulina Luna didn't just write a letter. She didn't just make a polite request through proper channels. She demanded answers. And today, November 5th, 2025, NASA is sitting down with her to talk about 3I Atlas, whether they like it or not. Think about that for a moment. We are living through the passage of only the third confirmed interstellar object in human history. An object that has displayed not one, not two, but 10 documented anomalies that challenge our understanding of cometary physics. An object that just completed its closest approach to the Sun 6 days ago on October 29th. And yet, since October 1st, when the government shut down, NASA has released exactly 0 images, 0 data updates, 0 meaningful information to the scientific community or the public. 0. The timing is almost too convenient. 3I Atlas reaches the most critical phase of its journey, the phase where any technological signature would be most obvious, the phase where a natural comet would display its most violent activity. And suddenly, the agency responsible for observing it goes dark. The Mars Reconnaissance Orbiter captured images on October 2nd and 3rd when 3 Atlas passed within 30 million kilometers of Mars. Those images have a resolution of 30 kilometers per pixel, 3 times better than anything Hubble achieved. And they are sitting on a server somewhere, classified, restricted, withheld from the very scientists who could interpret them. Representative Luna's letter, dated October 31st, is remarkable not for its diplomatic language, but for what it reveals about the situation. She specifically requested the highest resolution high-rise camera images from those October observations. She asked for supplementary data from any Mars missions that detected unusual activity during the flyby. She requested observations from Parker Solar Probe, from Hubble, from James Webb. The letter reads like a shopping list of data that should already be public. Data that any transparent scientific organization would have released immediately. But here is where it gets interesting. Luna didn't write one letter. She wrote 2. The first, back on July 31st, proposed redirecting the Juno spacecraft to intercept 3I Atlas. That letter was visionary, forward-thinking, based on analysis from Avibe showing how a specific thrust maneuver could position Juno to study the object when it passes Jupiter in March 2026. The estimated cost was $15 million for a 6-month mission extension, a rounding error in NASA's budget, a once-in-a-lifetime opportunity to study an interstellar visitor up close. NASA never responded. So Luna wrote a second letter and the tone shifted. This wasn't about future observations anymore. This was about data NASA had already collected and was refusing to share. The shift tells you everything you need to know. By October, Luna realized that NASA had been observing 3 Atlas extensively throughout its perihelion passage, but simply wasn't telling anyone what they found. Let that sink in. The space agency funded by taxpayer dollars, the organization that exists to advance human knowledge of the cosmos, observed an interstellar object during its most critical phase and decided the data was not for public consumption. Now you might be thinking, the government shutdown explains the delay. Bureaucracy, right? Red tape. Except multiple government sources confirmed to Defense Scoop yesterday that federal personnel have been monitoring 3 Atlas continuously throughout the shutdown. The All-Domain Anomaly Resolution Office, the Pentagon's UAP investigation unit, stated they are following reports relating to 3I Atlas closely. NASA officials told reporters they are tracking the interstellar comet and expect to discuss it with Luna during their scheduled meeting today, November 6th. So, they're watching, they're tracking, they're analyzing, they're just not sharing. The meeting today is not a courtesy. It's not a briefing NASA wanted to give. According to Luna's team, NASA and Pentagon officials have not briefed House lawmakers on the comet to date, despite its extraordinary nature, despite its statistical improbabilities, despite the fact that it represents one of the most significant astronomical events of the century. Luna had to reach out to the space agency herself, working with a scientist at Harvard, before NASA agreed to schedule a call. One call. After months of observations, after perihelion, after the moment when any technological system would reveal itself most clearly has already passed. A Loeb, the Harvard astrophysicist who's been publicly calling for data transparency, commended Luna's action. He emphasized that making NASA's information public is vital for academic research and pointed out that political delays caused by the shutdown could be holding back the release. But here is what Lowe also said, what he wrote in his own correspondence requesting the high-rise images. He sent his request directly to Professor Alfred McEwen at the University of Arizona, the principal investigator for the high-rise camera team. He received no response. Think about that. One of the most prominent astrophysicists in the world, someone who has briefed Congress on UAP and national security topics, someone who literally wrote the papers analyzing 3 eyelaces anomalies, cannot get a response from the team that took the images. Not a denial, not an explanation, just silence. This is not how science works. This is not how transparent government works. This is how classified programs work. This is how information control works. And it's not just American scientists being frozen out. The International Asteroid Warning Network, a United Nations-endorsed group focused on planetary defense, initiated a campaign to monitor 3I Atlas. It's the first interstellar object they have ever targeted for coordinated observation. They scheduled a workshop for techniques to correctly measure comet astrometry, with the campaign running from November 27th through January 27th, 2026. Registration was required by November 7th, but that campaign focuses on astrometry, on measuring position and trajectory. It doesn't address the elephant in the room, which is, what did the Mars Reconnaissance Orbiter actually see on October the 2nd and 3rd? What did Parker Solar Probe detect as 3I Atlas dove toward perihelion? What are the spectroscopic signatures that Webb captured post-perihelion? We know some things. Fresh data released just yesterday from the Minor Planet Center and NASA's Jet Propulsion Laboratory covers October 31st through November 4th. The post-perihelion analysis shows 3 Atlas brightened by a factor of 5 in the green band. The non-gravitational acceleration, which was already detected at 3.7 standard deviations, is confirmed. The object is accelerating in plane along its trajectory with no vertical component. That means it's not wobbling like a natural comet venting gas. It's accelerating cleanly, purposefully. The acceleration requires, if natural, that 3 Atlas lost more than 13% of its total mass near perihelion. 13%. For context, that is an absurd amount for an object of this size and speed. If it happened, there should be a massive cloud of gas surrounding the nucleus, a coma so large and obvious that every telescope pointed at it would see it immediately. And yet, preliminary post-perihelion images, the few that have been made public, do not show evidence of such massive outging so far. Lowe has been clear about what this means. If James Webb observes 3 Atlas in December and detects a massive outage consistent with losing 13% of its mass, case closed. It's a natural comet with extreme but explainable properties. But if Webb looks in December and does not find that massive coma, then the acceleration must have resulted from something other than cometary evaporation, something other than natural processes. The December observations are coming. They are scheduled. Multiple ground-based telescopes, Hubble, Webb, hundreds of instruments will point at 3I Atlas as it reaches its closest approach to Earth on December 19th. That's 44 days from now. 44 days until we get the answer. But here is the question nobody in power wants to ask out loud. What if NASA already knows the answer? What if the observations from October, the data being withheld, the images sitting on classified servers, already show whether 3 Atlas has the massive coma required by natural explanations? What if that's why they're not releasing anything? Luna's team made it clear that they want to see images of 3 Atlas. Not reports, not summaries, not carefully worded press releases. Images, raw data. The kind of information that scientists around the world can analyze independently, that amateurs with the right equipment can verify, that cannot be spun or sanitized or selectively edited to support a predetermined conclusion. This is not conspiracy thinking. This is basic scientific transparency. When the Hubble Space Telescope images an object, those images go into a public archive. When James Webb takes spectra, the data gets released to the community. When the Mars Reconnaissance Orbiter photographs the Martian surface, those images are available to researchers worldwide. There is no legitimate reason for 3I Atlas data to be treated differently unless that data shows something NASA is not ready to discuss publicly. The story exploded into mainstream consciousness in an unexpected way. Kim Kardashian, of all people, tweeted directly at NASA Administrator Shah Duffy asking about 3 Atlas, and NASA responded. Their response was dismissive, almost condescending. They claimed it is just the 3rd interstellar comet to pass through our solar system with no aliens and no threats. Just a comet. Nothing to see here. Move along. Except it's not just a comet. It's a comet with 10 documented statistical anomalies. It's a comet that arrived from within 9 degrowns of the WOW signal direction, a 6% probability. You stack those probabilities, you multiply 0.2% by 0.05% by 0.6%, 6% by 1%. You end up with numbers so small, they become almost meaningless. 1 in a million, 1 in 10 million, 1 in 100 million. Either we are witnessing the single most statistically improbable natural object ever observed, an object that breaks every rule of cometary physics while remaining technically natural, or we are witnessing something else, something that was designed, something that was sent, something that maneuvered into a trajectory that would bring it close to multiple planets in our solar system while remaining hidden from Earth during the most critical phase of its journey. And the agency responsible for observing it, for analyzing it, for determining its nature, is withholding the data that could answer those questions. Representative Luna is asking the right questions. She's using her authority to force transparency. She is not claiming 3I Atlas is alien technology. She's simply saying the American people, the scientific community, the world, deserves to see the data and make their own assessments. That should not be controversial. That should not require congressional intervention. That should be the default position of any scientific organization. The meeting today will tell us a lot. If NASA releases the high-rise images, if they provide access to the Parker Solar Probe data, if they open the James Webb spectroscopic observations to independent analysis, then we will know they are serious about transparency. If they provide more carefully worded statements, more promises of future releases, more excuses about shutdown delays and processing times, then we will know something else entirely. We will know they are buying time, and the question becomes, time for what? Time to analyze the data themselves before sharing it? Time to coordinate a response with other agencies? Time to prepare the public for conclusions they think we are not ready to hear? Or time for 3I Atlas to leave? To pass beyond our ability to observe it closely, to exit the solar system and take its secrets with it into the darkness between stars. December 19th. That is when 3 Atlas reaches its closest approach to Earth. That is when we will have our best opportunity for detailed observation. That is when the telescopes will tell us whether the massive coma required by natural explanations actually exists. But NASA already has data from perihelion. They already know more than they are saying, and until Representative Luna's intervention, they seemed content to keep it that way. Something shifted this week. Washington blinked. The question is whether they blinked because they realized transparency was necessary or because they realized the pressure was becoming impossible to contain. 44 days until December 19th. 44 days until we see whether 3I Atlas has the coma that natural physics demands. But the images from October exist right now. The data exists right now. The answer might already be sitting in NASA's archives, and they are not showing us the impossible physics. Post-perihelion acceleration without a trace. The numbers came in yesterday, November 5th, 2025. The Minor Planet Center and NASA's Jet Propulsion Laboratory released fresh orbital data covering October 31st through November 4th, post-perihelion. After the closest approach, after the moment when 3I Atlas experienced maximum solar heating and should have displayed its most dramatic cometary activity, and the physics makes absolutely no sense. 3I Atlas is currently sitting 206 million kilometers from the Sun, 1.38 astronomical units. That is its present position as the data updates. And it is accelerating, not drifting, not coasting on its hyperbolic trajectory out of the solar system. Accelerating. The non-gravitational acceleration stands at 3.7 standard deviations. Now that is statistically robust. That is not measurement error. That is not noise in the data. The acceleration has two components, both in the orbital plane of 3I Atlas. First, a radial component pushing away from the Sun. Second, a transverse component relative to the Sun's direction. When you normalize these values to one astronomical unit, you get specific numbers. The radial acceleration away from the Sun measures 1.136 astronomical units per day squared. The transverse acceleration measures 3.7, 10 pre to 7th astronomical units per day squared. Those numbers mean something very specific when you apply momentum conservation. When an object accelerates in space without an external force, it must be expelling mass. Rockets work this way, comets work this way. You push something out the back, you move forward. Basic Newtonian physics. The ratio between the acceleration you achieve and the mass you lose depends on how fast you eject that mass. A Loeb ran the calculation. The perihelion passage time for 3I Atlas, the duration it spent near closest approach, equals the perihelion distance divided by the perihelion speed. 203 million kilometers divided by 68 kilometers gives you roughly 1 month. During that month, with the measured non-gravitational acceleration of 94 kilons per day squared at perihelion, 3I Atlas would have lost a specific fraction of its total mass. 13% divided by the ejection velocity in units of 300 ms. 300 ms represents the thermal speed of molecules at the surface temperature of 3I Atlas near perihelion. That is the maximum expected value for a natural comet. Gas molecules vaporizing from the surface heated by sunlight cannot move faster than their thermal velocity unless something accelerates them, unless there is a mechanism beyond simple evaporation. So if 3I Atlas is natural, if it is accelerating through the rocket effect of normal cometary outgassing, it must have lost more than 13% of its mass during perihelion passage. More than 13%. 1/8 of its total bulk, vaporized, ejected, blown away by solar heating in the span of a single month. That is not how comets behave. That is catastrophic mass loss. That is the kind of event that would leave an enormous cloud of gas and dust surrounding the nucleus, a coma so massive and bright that every telescope in the world would see it immediately. The kind of coma that would dwarf anything observed during the approach phase. The kind of coma that would make 3 Atlas visible to amateur astronomers with backyard equipment. Here is what we actually see in the preliminary post-perihelion images. Nothing. No massive coma, no obvious expansion of the gas cloud, no evidence of the violent outgassing required to explain the acceleration through natural processes. The brightening is real. 3 Atlas brightened by a factor of 5 in the green band between early October and early November. That is confirmed. But brightening and mass loss are not the same thing. Something can get brighter without losing 13% of its mass. Something can glow more intensely if the mechanism producing the light changes. Low outlined the contrast clearly. If 3I Atlas is natural, the brightening and blue color near perihelion result from carbon monoxide, positive ion emissions, and massive cometary mass loss. The numbers require it. The physics demands it. You cannot accelerate this much while ejecting gas this slowly without losing enormous amounts of material. But if 3I Atlas is artificial, if it contains a technological propulsion system, then everything changes. A rocket engine can expel gas at much higher velocities than thermal speeds. Chemical rockets eject exhaust at 2 to 4 km/s. Ion drives achieve even higher exhaust velocities. With a higher ejection speed, you need far less mass to produce the same acceleration. The 13% requirement drops dramatically. You could explain the same acceleration with only a small fraction of the nucleus mass converted to propellant. And a hot engine, an engine producing thrust, would glow. It would emit light. It would appear brighter. It would shift toward blue wavelengths if the temperature was high enough. Everything observed during perihelion becomes explainable, not through catastrophic evaporation, but through controlled, powered flight. The acceleration itself reveals something crucial. It is entirely in plane. Both components, radial and transverse, lie within the orbital plane of 3I Atlas. There is no vertical component. None. The object is not wobbling. It is not tumbling. It is not venting gas randomly from a rotating irregular nucleus like natural comets do. Natural comets spin. As they spin, jets of gas erupt from their surfaces in different directions, creating a net force that changes direction as the nucleus rotates. This produces acceleration components in all 3 dimensions, including perpendicular to the orbital plane. It creates wobble. It creates unpredictability. 3I Atlas is accelerating cleanly along its trajectory. The force vector stays in plane. That suggests control. That suggests directionality. That suggests something maintaining a specific orientation as it thrusts. You can explain in plane acceleration naturally if the outgassing is extremely asymmetric, if jets form only on one side of the nucleus and always point in specific directions. But then you need to explain why. Why would a natural comet develop such perfectly directed outgassing? Why would it maintain that configuration throughout perihelion without the random variation seen in every other comet ever observed? The timing makes it worse. During July through September 30, Atlas displayed no non-gravitational acceleration. Analysis of 4,022 data points from 227 observatories showed purely gravitational motion. The object followed Newton's laws perfectly. No thrust, no jets, no anomalous forces. Then it approached perihelion, then the acceleration appeared. Then the physics became impossible to reconcile with natural processes. If this was an engine turning on, it would make perfect sense. You coast inbound to conserve propellant. You wait until perihelion, until the optimal moment for a trajectory adjustment. Then you fire your thrusters. The object means burns at perihelion are more efficient. Every spacecraft mission to the outer solar system uses perihelion burns to maximize velocity change. It is basic orbital mechanics. 3I Atlas executed what looks exactly like an oath maneuver. It accelerated at perihelion when such acceleration would be most effective. And it did so within plane thrust, with controlled directionality, with no evidence of the massive mass loss that natural explanations require. The brightening by a factor of 5 compounds the mystery. Natural comets brighten as they approach the sun, but the rate follows predictable patterns based on heliocentric distance. You can model it. You can forecast it. The relationship between distance and brightness is well established for cometary populations. 3 Atlas brightened faster than any known comet at similar distances from the sun. The authors of the recent paper analyzing its perihelion brightness stated explicitly that the reason for this rapid brightening remains unclear. It far exceeds the brightening rate of most Oort cloud comets under comparable conditions, and it became bluer than the sun. Think about that. The sun has a surface temperature of 5,800 degrees Kelvin. Its photosphere emits light with a specific spectrum, a specific color distribution. Dust-scattered sunlight appears redder than the sun because dust grains absorb and re-radiate energy, cooling the light. The nucleus of a comet, being much colder than the sun, should also appear redder. 3 Atlas became bluer than the sun. That means something hotter than the solar photosphere was contributing to the observed light, either gas emissions at extreme temperatures or a heat source on the object itself producing blue shifted radiation. Carbon monoxide positive ions can produce blue emissions. That is the natural explanation. But CO positive requires specific ionization conditions and should appear in spectroscopic observations as distinct emission lines. The preliminary spectra show unusual gas ratios, show strange compositions, but the complete spectroscopic analysis explaining the blue color through natural processes has not been convincingly demonstrated. The alternative is a hot surface, a surface heated beyond what solar irradiance alone can achieve. A surface glowing with its own thermal emission, an engine nozzle, a propulsion system exhaust port, something technological. Lowe has been careful to present both possibilities. He acknowledges 3I Atlas is most likely natural, but he emphasizes that the anomalies require serious consideration of technological origins because of the implications to humanity if that assessment proves correct. This is not sensationalism. This is risk analysis. If there is even a small probability that an interstellar object displays technological signatures, we must investigate thoroughly. The stakes are too high to dismiss the possibility without definitive evidence. And here is the problem. The definitive evidence exists. It exists right now. The observations from October, the data from perihelion passage, the high-resolution images from Mars, reconnaissance orbiter, the spectroscopy from James Webb, the particle measurements from spacecraft near the sun, all captured the moment when any technological system would be most active and most obvious. That data exists. NASA has it, and they are not releasing it. The post-perihelion data published yesterday gives us pieces. It confirms acceleration. It shows brightening. It establishes that something extraordinary happened near closest approach. But it does not include the imaging data that would show whether a massive coma formed. It does not include complete spectroscopic analysis explaining the blue color. It does not include high-resolution photographs revealing the nucleus geometry and surface features. Those observations were made. Mars Reconnaissance Orbiter photographed 3I Atlas on October 2nd and 3rd from a distance that provided 30 kilodot per pixel resolution. That is 3 times better than Hubble achieved from Earth. At that resolution, you could see structure. You could see whether the coma was symmetric or asymmetric. You could measure the actual size and distribution of any gas cloud. Parker Solar Probe was near the Sun during perihelion passage. It carries instruments designed to measure solar wind, particle densities, magnetic fields, plasma characteristics. If 3 Atlas released massive amounts of gas, Parker would have detected it. If 3 Atlas produced unusual electromagnetic signatures, Parker would have recorded them. James Webb observed 3 Atlas back in August at 332 astronomical units. It detected a carbon dioxide-dominated coma with a CO2 to water ratio of 7.61. That ratio was already extreme, already 4.5 standard deviations above the trend for known comets. But August was inbound. August was before perihelion. If massive outgassing occurred at perihelion, Webb's December observations should show a dramatically different signature. The December observations are scheduled. They will happen. Ground-based telescopes, Hubble, Webb, hundreds of instruments worldwide will point at 3 Atlas during its closest approach to Earth on December 19th. We will get data. We will get spectroscopy. We will see whether the massive coma required by natural explanations actually formed during perihelion. But we should not have to wait until December to know whether massive outgassing occurred in October. We should not have to infer the answer from future observations when direct observations from perihelion already exist in classified archives. The physics of what happened is encoded in data captured weeks ago. The answer is available now if NASA chooses to release it. The acceleration is confirmed, the brightening is confirmed, the blue color is confirmed. What is not confirmed is whether these observations match the predictions of natural cometry processes or whether they represent something fundamentally different. 13% mass loss leaves evidence. It leaves a massive coma. It leaves spectroscopic signatures. It leaves patterns in the brightness variations and color changes that distinguish thermal evaporation from other mechanisms. All of that evidence was captured during perihelion passage by multiple spacecraft and telescopes. And none of it has been released to the scientific community. The non-gravitational acceleration could be natural, extreme, unprecedented, statistically improbable, but technically possible within the boundaries of cometry physics if you make generous assumptions about volatility and composition. Or it could be artificial, controlled thrust from a propulsion system expelling gas at high velocity, producing in plane acceleration consistent with orbital maneuvering. The data to distinguish these possibilities exists. The observations were made, the measurements were recorded. We are not waiting on future events to settle this question. We are waiting on declassification. We are waiting on transparency. We are waiting on an agency that has the answers to share them with the world. December will bring new observations. December will show us what 3 Atlas looks like after perihelion during its outbound journey as it exits the inner solar system forever. Those observations will constrain the models. They will tell us whether continued outgassing supports natural explanations. But the story of what happened at perihelion, the moment of maximum heating and maximum activity, is already written in data NASA refuses to show us. The physics is impossible to reconcile with natural processes unless that data reveals something we have not yet seen. And the longer NASA waits to release it, the more questions arise about what they are hiding and why. December's verdict, the coma that will decide everything. December 19th, 2025. Mark that date, write it down, set a reminder. Because that is when 3I Atlas reaches its closest approach to Earth at 269 million kilometers. And that is when we get the definitive answer to the question that has haunted this entire saga. Does the massive coma exist or not? James Webb Space Telescope is scheduled to observe 3I Atlas throughout December. Ground-based observatories around the world are coordinating campaigns. Hubble will point its instruments at the object. Hundreds of telescopes, professional and amateur, will capture whatever light 3 Atlas reflects as it moves through the constellation Virgo into Leo. And all of those observations will answer a single binary question. Is 3I Atlas surrounded by an enormous cloud of gas consistent with losing 13% of its total mass during perihelion, or is it not? There is no middle ground here. The physics Loeb calculated is unambiguous. If 3I Atlas accelerated through natural cometry outgassing, through the rocket effect of vaporizing ice heated by the sun, then momentum conservation requires massive mass loss. You cannot cheat conservation laws. You cannot accelerate without expelling mass. The only variable is how fast you expel it. At thermal velocities, 300 nanometers mass, you need to lose 13%. If the ejection velocity is higher, if there is some mechanism accelerating the gas beyond thermal speeds, you lose less mass, but you still lose a measurable, detectable amount. And that lost mass forms a coma, a cloud, a halo of gas and dust surrounding the nucleus that scatters sunlight and emits spectroscopic signatures. The coma should be obvious. It should be massive. It should be much larger and brighter than anything observed during the approach phase between July and September. Because during those months, 3I Atlas displayed no non-gravitational acceleration. During those months, it was passive, dormant, following a purely gravitational trajectory with minimal outgassing. Then perihelion happened. Then the acceleration appeared. Then something changed fundamentally about the object's behavior. And if that change was natural heating causing catastrophic evaporation, the coma in December should reflect that transformation. It should be impossible to miss. Webb observed 3 Atlas back on August 6th at 332 astronomical units from the Sun. The spectroscopic data revealed a carbon dioxide-dominated coma. The CO2 to water ratio measured 7.6.1. That is extreme. That is 4.5 standard deviations above the trend for long-period and Jupiter family comets. Only one known comet, C2016 R2, shows a comparable ratio. And that object is considered an outlier, an anomaly in cometary science. But August was inbound. August was before perihelion. August was before the acceleration began. If massive outgassing occurred at closest approach, if 13% of the nucleus vaporized into space, the December observation should show a dramatically different picture. The coma should be orders of magnitude larger. The gas production rates should be elevated. The spectroscopic signatures should indicate ongoing vigorous activity. Lowe has been explicit about what this means. If Webb detects a massive outgassed coma in December, case closed. 3I Atlas is natural, extreme, unusual, statistically improbable in multiple ways, but ultimately a comet behaving according to physics we understand. The acceleration came from evaporation. The brightening came from reflected sunlight off expanding dust clouds. The blue color came from carbon monoxide positive ion emissions. Everything fits within the boundaries of exotic but natural processes. But if Webb looks in December and does not find that massive coma, then the acceleration must have resulted from a different cause than cometary evaporation. Not might have, not could have, must have. Because conservation of momentum is not optional. You cannot accelerate in space without pushing mass in the opposite direction. If the coma that should exist does not exist, then the mass was expelled some other way, through a different mechanism, through something that is not thermal evaporation of surface ice. The preliminary post-perihelion images do not show obvious evidence of massive outgassing that was noted in the data released yesterday. But preliminary images are not definitive. They are not high resolution. They are not spectroscopically analyzed. They are snapshots from spacecraft and telescopes that were not optimized for detailed cometary observations. December changes that. December brings focused, dedicated high-resolution observations specifically designed to characterize 3I Atlas in detail. Webb's infrared spectroscopy can measure gas production rates. It can identify molecular species. It can quantify the mass of material in the coma. Ground-based telescopes with adaptive optics can resolve spatial structure. They can see whether the coma is symmetric or shows directional features. Hubble can provide visible wavelength imaging that captures dust distributions. All of that data synthesized together will tell us whether the mass loss predicted by natural explanations actually occurred. There is no ambiguity in what we should see. If 3I Atlas is a normal comet that got extremely active near perihelion, The gas should be there. The coma should be huge. The spectroscopic lines should be bright. And if they are not, if December observations show a compact object with no evidence of the massive gas cloud required by momentum conservation, then we have a problem. Then the acceleration needs a different explanation. Then every assumption about 3I Atlas being natural comes into question. The carbon dioxide ratio from August is already troubling. 7.66 to 1 CO2 to water is not normal. It suggests either an intrinsically CO2-rich nucleus, possibly indicating formation near the CO2 ice line in the parent protoplanetary disk, or exposure to high levels of radiation that depleted water ice preferentially. Both scenarios are possible, both are natural, but both push the boundaries of what we typically observe in comets. The paper analyzing Webb's August data proposed that 3I Atlas might contain ices exposed to higher radiation levels than solar system comets. Interstellar space is not empty. Cosmic rays permeate the galaxy. Over billions of years, a small object drifting between stars would accumulate radiation damage. Water ice, being less stable under radiation, could sublimate or decompose, leaving behind more refractory species like carbon dioxide. That explanation works for the August observations. It explains the unusual gas ratios. It fits with the idea that 3I Atlas has been wandering the galaxy for 3 to 11 billion years based on its velocity and trajectory. But it does not explain the acceleration. It does not explain why an object that showed no activity for months suddenly started accelerating at perihelion with no corresponding increase in coma brightness proportional to the required mass loss. The water content in the coma is only 4% by mass. 4%. Water is supposed to be the dominant volatile in comets. It is the primary driver of cometary activity in the inner solar system. When a comet gets close to the sun, water ice vaporizes, creating the dramatic tails and comas that make comets visible. 3 Atlas has almost no water. Its activity is driven by carbon dioxide and carbon monoxide, both of which sublime at lower temperatures than water. That means 3 Atlas should have been active much farther from the sun than typical comets. It should have developed a large coma early in its approach. It should have been bright and obvious from great distances, but it was not. It was discovered at 4.5 astronomical units already inside the asteroid belt. It was faint. Its coma was modest. Only as it approached perihelion did the brightness surge. Did the activity increase? Did the acceleration appear? That is backwards. That is opposite to what you expect from a carbon dioxide-driven comet. Unless something else was happening. Unless the early observations showed a dormant object coasting inward and the perihelion observations showed an active system initiating operations. Unless the lack of early activity was not because the volatiles were stable at low temperatures, but because they were not being vented. Because the object was conserving mass. Because it was waiting. December will settle this. December gives us the post-perihelion state. December shows us whether 3 Atlas is surrounded by the gas cloud that natural physics demands, or whether it remains compact, enigmatic, unexplained. The timing of closest approach to Earth is almost too perfect. December the 19th places 3I Atlas in the pre-dawn sky for Northern Hemisphere observers. It will be in Virgo, moving toward Leo at an altitude that allows ground-based observations with large telescopes. The moon will be past full, less interference for sensitive instruments. The geometry is optimal for spectroscopy, for imaging, for coordinated campaigns. It is as if the universe conspired to give us one clear shot at answering this question before 3A Atlas exits the inner solar system forever. One moment when all the conditions align. One window when every major telescope can point at the object and collect the data needed to distinguish natural from artificial. But here is the problem. We should not need December to answer this question. We should already know. The observations from perihelion, the data captured in October by Mars Reconnaissance Orbiter, by Parker Solar Probe, by spacecraft watching 3 Atlas pass through its closest approach to the Sun, those observations already contain the answer. If a massive coma formed at perihelion, the October data shows it. If the nucleus remained compact with minimal outgassing, the October data shows that too. The December observations will confirm what already happened. They will provide additional constraints, more spectroscopy, better spatial resolution. But they are not revealing new information about perihelion. They are documenting the aftermath. NASA has the perihelion data. They know whether the massive coma formed. They know whether the acceleration can be explained through natural outgassing. They know whether December is going to validate cometary physics or overturn it. And they are not telling anyone. That silence speaks volumes. If the October data clearly showed a massive coma, if the observations unambiguously supported natural explanations, there would be no reason to withhold it. You release the images, you publish the spectroscopy, you let the scientific community analyze the results and confirm that 3 Atlas, despite its anomalies, is ultimately a natural object with extreme but explainable properties. The fact that NASA is sitting on the data, that they are waiting, that they scheduled a meeting with Congresswoman Luna only after political pressure forced their hand, suggests the October observations did not provide the clear natural explanation everyone expected. If they had, we would have seen them by now. The data would be public. The mystery would be solved. Instead, we have silence, and we have December 19th approaching, and we have the entire astronomical community preparing for observations that will either validate the cometary hypothesis or demolish it. No middle ground, no ambiguity. Either the coma exists or it does not. Either momentum conservation is satisfied by observable mass loss or it is not. 44 days from now, we will know. The telescopes will point, the instruments will record, the data will process, and somewhere in that flood of photons and spectra and images, the answer will emerge. 3 Atlas will reveal whether it is the most anomalous natural object ever observed or whether it is something else entirely. Something that does not belong to any category we have previously encountered. Something that requires new explanations, new physics, new frameworks for understanding what is possible in the universe. December 19th, 2025. The verdict arrives, and there is no appeal. The nickel anomaly. Industrial signatures in deep space. Nickel should not be there, not in those quantities, not without corresponding iron, not vaporizing from a comet's surface at temperatures where nickel should remain solid, locked in refractory minerals, inert. Yet spectroscopic observations from multiple facilities detected it. Nickel vapor in the coma of 3I Atlas. Not trace amounts, not barely detectable signals buried in noise. Prominent emission lines indicating substantial nickel abundance in the gas cloud surrounding the nucleus. The Very Large Telescope in Chile confirmed it. Ground-based spectroscopy during the approach phase showed nickel emissions at levels unprecedented for comets. And here is what makes it extraordinary. The nickel-to-iron ratio is inverted, backwards, completely opposite to what natural cosmochemistry predicts. In normal stellar material, in asteroids, in meteorites, in every natural object formed from the interstellar medium, iron outnumbs nickel by a factor of roughly 20 to 1. That ratio reflects primordial nucleosynthesis. It reflects how stars forge elements through fusion and supernova processes. Iron is more abundant because the nuclear physics favors its production. Nickel is a minor constituent, present but subordinate. 3I Atlas shows more nickel than iron in its coma, far more. The spectroscopic ratios indicate nickel emissions dominating over iron by factors that define natural explanations. And that ratio, that inversion, matches something very specific. Industrial nickel alloys, stainless steel, superalloys used in high-temperature applications like jet engines and rocket nozzles. engineered materials where nickel is deliberately concentrated because of its desirable properties. Nickel resists oxidation. It maintains strength at high temperatures. It forms protective oxide layers that prevent corrosion. Engineers love nickel for applications where materials must survive extreme thermal and chemical environments. Spacecraft components use nickel alloys. Propulsion systems use nickel alloys. Anything designed to operate in the harsh conditions of space or high-energy environments uses nickel alloys. 3-2 Atlas is outgassing nickel at ratios consistent with industrial production, not natural cosmochemistry. That is not speculation. That is direct observation. The emission lines are there in the spectra. The ratios are measured. The chemistry is wrong for natural formation and right for technological manufacturing. But wait, it gets stranger. Nickel should not be vaporizing at all at the temperatures 3-2 Atlas experienced during early observations. Nickel has a boiling point of 2030 degrees RC. Metallic nickel remains solid at temperatures where water, carbon dioxide, and even carbon monoxide are long since vaporized. You do not get nickel vapor from a cold comet nucleus heated by distant sunlight, unless the nickel is not in metallic form, unless it is bound in volatile compounds that decompose at lower temperatures. One candidate is nickel tetracarbonyl. Nickel bonded to 4 carbon monoxide molecules. Nickel tetracarbonyl is a gas at room temperature. It forms when nickel metal reacts with carbon monoxide under specific conditions, and it decomposes when exposed to ultraviolet light, releasing nickel atoms and carbon monoxide. The hypothesis goes like this. 3 Atlas contains nickel tetracarbonyl in its interior or on its surface. As the comet approaches the sun, solar ultraviolet light breaks apart the compound. Nickel atoms and carbon monoxide molecules flood into the coma. The nickel produces the observed emission lines. The carbon monoxide contributes to the unusual gas ratios. That would be a natural explanation. Nickel tetracarbonyl can form in interstellar environments under the right conditions. It is not common, but it is possible. If 3I Atlas formed in a region rich in carbon monoxide and nickel grains, if radiation processing over billions of years created unusual surface chemistry, you could end up with volatile nickel compounds. But here is the problem. The nickel to cyanide ratio in 3 Atlas is orders of magnitude larger than any known comet, including Boris. Cyanide CN is a standard cometary volatile. It appears in the spectra of nearly every active comet. It is a reliable tracer of cometary composition. The ratio of nickel to cyanide should fall within a predictable range if both are products of natural sublimation from a mixed ice and dust nucleus. 3I Atlas violates that ratio by absurd margins. The nickel is too high, or the cyanide is too low, or both. The chemistry does not match any known population of comets, solar system, or interstellar. It is an outlier, a statistical anomaly with probability below 1%. You start stacking these anomalies, and the natural explanations require increasingly contrived scenarios. You need a comet that formed near the carbon dioxide Elene in a protoplanetary disk with unusual metallicity. You need that comet to be ejected into interstellar space and irradiated for billions of years, creating exotic surface chemistry. You need that same comet to arrive at our solar system on a trajectory aligned within 5 degrees of the ecliptic, with a timing that brings it near multiple planets while hiding it from Earth at perihelion. You need it to display a sunward jet, extreme polarization, water depletion, and now nickel emissions inconsistent with natural cosmochemistry. Each individual anomaly can be explained with effort, with creative modeling, with generous assumptions. But all of them together, all occurring in the same object, the probability becomes vanishingly small. The explanations become increasingly forced. Or you consider the alternative. 3 Atlas contains industrial nickel alloys because it was manufactured. because it is a technological object built by a civilization that uses nickel-based materials for structural components and propulsion systems. Because the nickel emissions are not from volatile compounds formed naturally, but from ablation, from thermal stress, from surfaces heated by internal systems or solar irradiation at perihelion. Spacecraft lose material. Thermal protection systems ablate, surfaces oxidize and sputter. Any technological object passing through the inner solar system would shed atoms and molecules into space, creating a thin coma of artificial composition. If that object used nickel alloys in its construction, those atoms would appear in spectroscopic observations. The nickel vapor was detected during the approach phase before perihelion, when 3I Atlas was still relatively cool. That argues for a volatile compound, sublimating rather than high-temperature ablation. But the post-perihelion observations, the data from October that NASA is withholding, would show whether nickel emissions increased, decreased, or changed character at closest approach. That data would distinguish between passive outgassing of volatile compounds and active thermal processes driven by internal or external heating. We do not have that data. We have August spectroscopy from ground-based telescopes showing nickel emissions during approach. We have the James Webb observations from August showing carbon dioxide dominance. We do not have perihelion spectroscopy. We do not have high-resolution chemical analysis from the moment when any technological system would be most active and most obvious. The nickel is not the only chemical anomaly. The water content is 4% by mass. 4%. That is depleted beyond what any normal cometary formation model predicts. Water is the most abundant ice in molecular clouds. It is the dominant volatile in asteroids and comets formed in the outer solar system. You cannot easily make a comet with only 4% water unless something removed the rest. Radiation processing can deplete water over billions of years. Cosmic rays break molecular bonds. Water ice sublimates or decomposes. More refractory species remain. That works as an explanation for an ancient interstellar object that has been wandering the galaxy far longer than solar system comets have existed. But radiation processing is gradual. It affects the entire object uniformly over time. It does not create the sudden onset of activity 3 Atlas displayed at perihelion. It does not explain why an object depleted in water by billions of years of radiation suddenly started outgassing vigorously at closest approach to the sun. Unless the water was not depleted by radiation. Unless the interior composition is fundamentally different from surface composition. Unless the object is not a uniform mixture of ice and dust, but a structured body with distinct layers, compartments, systems. Unless the 4% water is not a bulk property, but a measurement of what is venting from specific regions. The extreme negative polarization adds another layer of strangeness. Polarization measures how light scatters off particles in the coma. Different particle shapes, sizes, and compositions produce different polarization signatures. Comets typically show positive polarization at certain angles, negative at others, following patterns established by decades of observations across hundreds of objects. 3 Atlas shows extreme negative polarization, unprecedented for all known comets, including Boris. The particles in its coma scatter light in ways that do not match natural dust populations. Either the grain composition is highly unusual, the size distribution is atypical, or the shapes are non-standard, or all three. Manufactured particles could produce unusual polarization. Spherical metal grains, engineered dust, ablation products from artificial surfaces. Any of these would scatter light differently than natural silicate and carbon grains produced by grinding and shattering of primordial material. The spectra, the chemistry, the polarization, the nickel emissions, they are all pieces of a puzzle that does not assemble into a coherent picture using natural explanations alone. Each piece can be forced to fit with sufficient effort, but the overall image remains distorted, unconvincing, statistically implausible. The alternative is simple. 3 Atlas is artificial. It contains industrial materials because it was constructed. It displays unusual chemistry because its composition reflects engineering choices, not natural formation processes. It shows nickel emissions because nickel alloys are superior materials for spacecraft construction. It depletes water because biological or technological systems do not require massive water reserves for operation. It accelerates a perihelion because it fired an engine. That explanation fits all the observations. It requires no contrived scenarios, no stacked improbabilities, no generous assumptions. It simply asks us to consider the possibility that we are observing something made rather than something born, something sent rather than something ejected, something intentional rather than something random. The December observations will not resolve the nickel question directly. Spectroscopy in December will show whether chemical emissions continue, whether the composition evolves, whether new species appear or old ones fade. But the nickel emissions from August are already in the data. The industrial ratios are already measured. The anomaly is already established. What we need is the perihelion spectroscopy. The observations from October, when 3 Atlas was hottest, most active, most thermally stressed. If the nickel emissions spiked at perihelion, if new metals appeared, if the chemical signatures shifted toward ablation rather than sublimation, that would tell us something profound about the nature of the object. NASA has that data. Ground-based observers captured spectra during perihelion approach in September and October. Space-based instruments monitored the object continuously. The chemistry of perihelion is recorded, analyzed, archived, and it is being withheld from the scientific community for reasons that remain unexplained. The nickel should not be there, but it is, and its presence combined with every other anomaly, every other statistical improbability, every other deviation from natural expectations, paints a picture that becomes harder to ignore with each new observation. December will add more pieces to the puzzle, but the image is already forming and it does not look natural. Hidden encounters, what the Mars orbiter saw and NASA won't release. October 2nd and 3rd, 2025. 3 Atlas passed within 30 million km of Mars. Close enough that spacecraft orbiting the red planet could photograph it with unprecedented resolution. Close enough that the Mars Reconnaissance Orbiter, with its high-rise camera capable of resolving features 30 km per pixel, could capture images 3 times sharper than anything Hubble achieved from Earth. Those images were taken, the observations were executed, the data was recorded and transmitted back to Earth. And then, nothing. Silence. No release, no publication, no announcement that some of the highest resolution images of an interstellar object ever captured were now available for scientific analysis. 4 weeks passed. Representative Anna Paulina Luna wrote her first letter requesting NASA redirect Juno to intercept 3 Atlas. No response. She wrote her second letter on October 31st, specifically demanding the high-rise images from October 2nd and 3rd. She requested supplementary data from any Mars missions that detected unusual activity during the flyby. She asked for observations from Parker Solar Probe, from Hubble, from James Webb. The letter reads like an inventory of data that should already be public. Observations that any transparent scientific organization would release immediately to enable global analysis and follow-up planning. Instead, NASA's email response stated the organization was closed due to a lapse in government funding and mailboxes were not being monitored. Except they were monitoring, they were observing. Multiple government sources confirmed that federal personnel continued tracking 3 Atlas throughout the shutdown. The All-Domain Anomaly Resolution Office acknowledged following reports closely. NASA officials told reporters they were maintaining observations with Hubble, Webb, tests, and other assets. The agency was not actually closed in any meaningful sense. They were collecting data, They simply were not sharing it. Avi sent his own request to Professor Alfred McEwen at the University of Arizona, principal investigator for the high-rise camera team. No response. One of the most prominent astrophysicists in the world, someone who literally wrote the papers analyzing 3I Atlas, cannot get a reply from the team that took the images he requested. Not a denial, not an explanation, just silence. Think about what that means. The images exist, they are processed, they are archived. Someone at the University of Arizona could attach them to an email and send them to Lowe in approximately 5 seconds. But they do not. They ignore the request. They ignore congressional inquiry. They ignore the fact that the entire astronomical community is desperate for the data needed to understand what happened during perihelion. The high-rise images are critical because they offer a perspective impossible from Earth. When Hubble photographed 3I Atlas on July 21st, the geometry was nearly edge-on. Earth and the Sun were separated by only 10 degrees relative to distant 3 Atlas. That means Hubble was looking at the comet almost directly into the sunlight, seeing primarily the sunward-facing hemisphere and tail. The Mars Reconnaissance Orbiter observed from the side, a 90-degree different viewing angle. That perspective reveals structure invisible from Earth. It shows the spatial distribution of any coma. It captures asymmetries in outgassing. It images the nucleus geometry without the confusion of edge-on projection effects. At 30 kilometers per pixel resolution, features become visible. You can measure the actual size of the nucleus. You can see whether the coma is symmetric or shows directed jets. You can distinguish between diffuse clouds of gas and dust versus compact emissions from specific locations. You can determine whether the object is a uniform sphere or an elongated body, or something with distinct components. All of that information exists in the October 2nd and 3rd images. All of it was captured during the critical phase when 3D Atlas was approaching perihelion, when activity was increasing, when any technological system would be preparing for maximum operations. The data is sitting in an archive somewhere, processed and ready for analysis. And it is being deliberately withheld. Why? What could those images possibly show that NASA is unwilling to release? If they showed a normal comet with a typical coma and dust distribution, there would be no reason to withhold them. You release the images. You let scientists analyze them. You publish papers describing the observations. You contribute to human knowledge. If the images showed something unusual, but still explainable through natural processes, you still release them. Unusual is interesting. Unusual generates papers, conferences, research funding. Scientists love unusual as long as it remains within the boundaries of natural phenomena. There is no incentive to suppress observations of an extreme but natural comet. The only reason to withhold the images is if they show something that cannot be easily explained as natural, something that raises more questions than it answers, something that would force the conversation in directions NASA is not prepared to explore publicly. The Mars flyby was not just about imaging. Multiple spacecraft at Mars carried instruments beyond cameras. The Perseverance rover has spectroscopic capabilities. The Curiosity rover monitors atmospheric composition. Orbiters carry magnetometers, particle detectors, plasma instruments. If 3I Atlas released unusual amounts of gas during its close approach, if it produced electromagnetic signatures, if it interacted with the Martian environment in detectable ways, those instruments would have recorded it. Representative Luna requested any supplementary data from Mars missions that detected unusual activity. That phrasing is specific, not routine observations, not standard monitoring, unusual activity. Something out of the ordinary, something that warranted special attention, something that multiple instruments flagged as anomalous. What did they detect? What registered as unusual enough to be specifically requested in a congressional letter? The fact that Luna knew to ask suggests she was briefed on something. Someone told her that Mars assets detected activity worth investigating. Someone gave her reason to believe the data exists and matters, and NASA is sitting on it. The Parker Solar Probe presents another piece of the puzzle. Parker orbits the Sun at close distances, diving through the corona to study solar wind and space plasma. During October, 3 Atlas passed through regions Parker monitors. If the comet released massive amounts of gas at perihelion, if 13% of its mass vaporized into space, Parker's instruments would have detected the plasma signatures, the particle densities, the shock waves created by cometary material interacting with the solar wind. Parker carries a wide field imager, a magnetometer, plasma detectors, particle counters. It is designed to measure exactly the kind of phenomena that massive cometary outgassing would produce, and it was positioned perfectly to observe 3I Atlas during perihelion passage, when any such outgassing would be at maximum intensity. Luna requested Parker Solar Probe observations. She asked for them specifically by name. That means someone briefed her about Parker's capabilities and position. Someone told her Parker data would be relevant to understanding 3 Atlas. Someone gave her reason to believe that probe detected something worth examining. What did Parker see? Did it detect the massive plasma cloud that natural explanations require? Did it measure particle densities consistent with 13% mass loss? Or did it observe something else? Something unexpected? Something that does not fit commentary models? We do not know because the data has not been released. Parker is operational. It transmits data regularly. The observations from October exist. They are analyzed. They are archived. And they are not being shared with the scientific community. Hubble and James Webb observations from perihelion are similarly absent from public archives. Hubble photographed 3I Atlas in July when it was far from the Sun. That image showed a teardrop-shaped cocoon of dust coming off the nucleus, normal cometary morphology. But Hubble should have continued observing as the comet approached perihelion in October. Those later observations would show how the coma evolved, whether it expanded dramatically, whether its structure changed in ways consistent with massive outgassing. Where are those images? Hubble operates continuously. It does not shut down for government budget lapses. Its observation schedule is planned months in advance. If 3I Atlas was on that schedule for perihelion monitoring, and it certainly should have been given its status as only the 3rd confirmed interstellar object, then images were captured in September and October. They exist. They have not been released. Nobody's explaining why. James Webb observed in August and captured spectroscopy showing carbon dioxide dominance that was published. The paper appeared in late August describing the unusual gas ratios. But Webb's observation schedule does not end in August. The telescope has limited time, carefully allocated to maximize scientific return. If Webb devoted precious observing hours to 3 Atlas in August, it almost certainly continued monitoring as the object approached perihelion. Where is that data? Where are the September and October spectra showing how the chemical composition evolved as 3I Atlas heated up? Where are the measurements of gas production rates during the critical phase when mass loss should have been maximum? Where is the spectroscopy that would definitively answer whether the brightening and blue color came from natural emissions or something else? The data exists. Someone at NASA can access it right now. Someone can pull up the files, read the spectroscopic lines, see exactly what 3I Atlas was outgassing during perihelion, and they are choosing not to share that information with anyone outside their organization. The ESA's JUICE spacecraft, Jupiter Icy Moons Explorer, passed within 64 million kilo of 3I Atlas on November 4th, just days ago. JUICE carries multiple instruments: Janus Visible Imager, MAGIS Infrared Spectrometer, ESCI Sub-EM Wave instrument capable of detecting coma's composition and surface properties. Those instruments were pointed at 3 Atlas. Observations were made. Data was collected. Has any of it been released? Has ESA published images, spectra analysis of what JUICE detected? Or are they coordinating with NASA, waiting for some agreed-upon timeline, following protocols that prioritize control over transparency? The Juno spacecraft will approach within 54 million kilometers of 3I Atlas on March 16, 2026. That is still months away, but Juno's trajectory is already set. The observation plans are already made. NASA knows exactly what instruments will be available, what data Juno can collect, what questions those observations might answer. Representative Luna's first letter in July urged NASA to extend the Juno mission to study 3 Atlas. The estimated cost was $15 million. The scientific return would be unprecedented. Close-up observations of an interstellar object using instruments designed to study composition, thermal emission, magnetic fields, particle environments. The kind of comprehensive characterization that remote observations can never achieve. NASA never responded to that proposal. They never explained why $15 million was too much to spend on a once-in-a-lifetime opportunity. They never engaged with the suggestion. They simply ignored it until congressional pressure forced them to schedule today's meeting. Why? Why pass up the opportunity to gather data that could definitively characterize 3I Atlas? Why refuse to redirect a spacecraft that could intercept the object and settle every question about its nature? Unless NASA already knows the answers. Unless the October data already told them everything they need to know. Unless the high-rise images, the Parker detections, the Webb spectroscopy, the Hubble observations already revealed the truth. And that truth is not something they are ready to share publicly. The pattern is unmistakable. Data exists from perihelion passage. Multiple spacecraft and telescopes captured observations during the critical phase. That data would answer fundamental questions about whether 3 Atlas is natural or artificial, whether it lost massive amounts of mass, whether its chemistry and morphology match natural cometry processes. And all of that data is being withheld deliberately, systematically, across multiple missions, multiple instruments, multiple organizations. Someone made a decision that this information should not be public. Someone decided that the images showing 3 Atlas at closest approach, at maximum activity, during the moment when any technological signature would be most obvious, should remain classified or restricted, or simply unavailable to the scientific community. Congresswoman Luna is forcing the issue. Today's meeting may produce results. NASA may agree to release the high-rise images. They may provide access to Parker data. They may explain the delay and offer a timeline for publication, or they may offer more excuses, more explanations about processing times and peer review requirements and data validation protocols. But the data exists right now. The truth about what happened at perihelion is encoded in observations already captured and analyzed. We are not waiting on future events. We are not waiting on December observations to reveal new information. We are waiting on declassification. We are waiting on transparency. We are waiting on an agency that has the answers to decide whether the public deserves to see them. October 2nd and 3rd, 30 million kilometers from Mars, 30 kilometers per pixel resolution, the clearest images of an interstellar object ever captured, and they are locked away, hidden, withheld for reasons nobody will explain. That is the story. That is the scandal. That is why Representative Luna had to intervene with congressional authority to force a meeting that should never have been necessary. The Mars Reconnaissance Orbiter saw something, and NASA does not want us to know what it is.